Hello, thank you for joining me on this short video, Sous Vide. My name's Andy Bowles and I'm a food lawyer. Now this is the 51st of a series of 100 short videos on UK food law topics. You may be watching this as part of our online training service, and if that's the case, in addition to this short video, you can watch an hour-long webinar on the topic. There is also an online training course which goes, I think, a couple of hours long, which goes into far more detail, and you can also download lots of reference materials. However, if you're joining me on our YouTube channel, well, you're very welcome to do so. So, sous vide. What is sous vide? Well, it's not who is sous vide, as you might have thought. It's not S-U-E, it's S-O-U-S vide. A literal translation would be under vacuum, and that gives away a bit of a clue about this processing technique that's used in catering and in manufacturing. So basically, a typical feature of a sous vide system is a two-stage one. You'd have, firstly, a vac pack stage. So you take a product like a fillet of fish or a fillet of beef or whatever it is you're going to sous vide. You place it into a plastic bag, into a vac pack machine, suck out all the air and seal it. So you now have a vac packed food. That's stage one. Stage two is that you will actually take that vac packed food and place it into a water bath. And the water bath is maintained at a particular temperature, so that you end up processing or cooking the food at a lower temperature than normal catering temperatures for a longer period of time to achieve a better characteristic in terms of, texture, flavour and so forth. So you've got those two stages, the actual vac pack and then the heat treatment in the water bath. But actually it's not as simple as that, because of course it depends how you approach this. It may be that in a catering environment, in a manufacturing environment, you might want to vac pack the food and then store it, so that when it comes to somebody coming into your restaurant and ordering fillet of beef, you don't have to prepare the fillet, put it into vac pack, blah, blah, blah. That stage already done. So you've got vac packed fillets ready to go. You just plop them in the water bath. So there may be additional storage steps in between the vac pack and the actual heat treatment. And in fact, it might be more complex than that, because you may have the raw material that gets stored, but then you might choose, for example, to have a larger piece of beef under vac pack. So when someone orders a food, you might then take it out, chop it into smaller fillets, re-vac pack and cook the smaller fillets. So there might be an element of some being taken out of storage and cooked, and some being returned to storage after previously being in storage. This is important because when I come onto it in a moment, a bit of a spoiler here, but one of the food safety concerns with the sous vide system, because of the use of vacuum packing and chilled foods, is the bacteria Clostridium botulinum. If you've watched the video on Clostridium botulinum on this series of 100, you'll know that that bacteria produces a neurotoxin, a very dangerous poison, but it can grow at refrigerated temperatures in the absence of oxygen. In other words, it will grow in certain foods in vac packs. So if you have a food that you're going to put through your sous vide system, well then there is potential for the food to be contaminated and for that Clostridium botulinum to grow out in the vac pack. So that's one particular concern here. So if you are running a sous vide system, you must, as a basic principle, when you're starting your system based on HACCP principles on this, when you're describing your food, you must identify the exact time, the amount of time that a product will spend under vacuum packing. And that includes the total time. Even if it's taken out and put back in again, you still look at the total time that that's been under vacuum packing. I'll explain that why in a moment. So it might be you get your raw material, you might store it, you might then take it out, vac pack it, you might then store it again, you might then take it out and put it in the water bath, and then actually you might store it again, because if you're in a restaurant, someone orders a fillet of beef, you probably won't be saying to them, that's fine, it'll be with you in 6 hours. I mean, you will want to maybe have done the previous steps, and you might have the ready sous vide product in storage, so that you can just take it out and perhaps put it in a frying pan just to finish it off and serve it up. If you're in manufacturing, the processes might be direct, so there might be you just follow one process one after the other. It doesn't matter. key part of any system based on HACCP principles for sous vide is that you understand your process. You understand how the food travels through that particular journey. Okay, so equipment, you'll have a vac pack typically, so a machine to extract air and seal the plastic pouch, and a water bath. And typically there are some fabulous water baths out there. With a water bath, the classic sort of components of a sous vide water bath would be that you have a unit sitting on top of a water bath with a little propeller underneath, and the propeller is there to circulate the water so that the temperature is remained even throughout the water bath. If you haven't got that circulation, you could have hot spots, or more concern, cold spots within the water bath. So you must make sure the water is travelling around. What you would do typically on a sous vide system is you set the temperature, you set the time, and you push a button and off it goes. So it's a bit like there's a heated element that goes into the water bath, a bit like a kettle element, and it heats the water up, the propeller gets it circulated, a probe will determine the temperature and will keep the temperature at the right temperature for the right period of time. So, what are the food safety concerns? Well, I've already said, I couldn't wait. I had to tell you, it was Clostridium botulinum. That is the biggest concern here. Not so much the bacteria. If you watch the video on Clostridium botulinum, you'll know it's not the bacteria that gets you, it's the neurotoxin that it forms if it's allowed to grow. And for Clostridium botulinum to grow, it needs time. That's why the time under vacuum is so important with sous vide systems. Because actually, if you just put a product into a vacuum pack and then you cook it and you take it out, because there's no time for the Clostridium botulinum to grow, it's just not an issue, so you haven't got to worry about it. It's typically when you're storing your Clostridium botulinum, you're storing your product under vacuum, for example, for more than 10 days. If you're doing that in total, and that includes if it's supplied to you under vacuum, it might be a product that's been supplied from your supplier and they've already vacuum packed, you count that as well. So 10 days might seem an awful long time for something to remain under vacuum, but it might not be that long in a supply chain. So that's one of the concerns. The other is that you are cooking the food in inverted commas at lower temperatures. I mean, you might be cooking the food in 60 degrees centigrade. Now we know that if you're cooking something like fish or meat, typically at catering temperatures, you'll be looking for a core temperature of 75 degrees centigrade. So a sous vide system relies on the fact that you might be cooking at lower temperature, but for much longer time. So you might cook it for hours at 63 or something, rather than just at 75 instantaneous. But because you're at lower temperatures, that's obviously, there is potential for Salmonella, E. coli 157 and other food poisoning bacteria to survive the process. There is also potential for cross-contamination. Remember, vac packers, if you're putting raw meat on your vac pack machine in order to put it through a sous vide system, but now you've got a vac pack machine and they're handy old things, those, and then you decide, oh, actually I'm going to start vac packing some cooked meats. You've got to be, you're moving into very dangerous territory. Remember, things like E. coli 157 might be present on raw meat, and if you watch the video on E. coli 157 that I've provided, you'll know it only takes a handful of bacteria to cause serious illness. So therefore, if you have even just a splash of blood onto a vac pack machine and then put cooked meat on it, there is the potential for disaster for you to actually transfer the E. coli 157 from raw meat to cooked meat. So separate machines would be most appropriate, but there are some circumstances where you can use the same machine and strip it down. Food Standards Agency have issued some guidance on this. If you subscribe to our online training, believe it or not, there's a webinar and an online training course which runs through this. Also, the water baths, you're putting raw food in there, and so you've got to be careful that you don't have cross-contamination. You have good quality water. You don't want to be sort of putting food into some sort of bacteria soup. So main concerns here would be, because it's vac packed, Clostridium botulinum. But if you've watched the video on Listeria monocytogenes that I produced, you'll also know that Listeria can grow at refrigerated temperatures, causes illness, but also can survive. It doesn't really grow very well, but it can survive and grows slowly in vac packed products, chilled foods. So that could be another one that could be of concern here. So is Clostridium botulinum always a risk? The answer is no. The thing about Clostridium botulinum, it is found pretty ubiquitously around in the environment, but in order for you to be poisoned by the neurotoxin, the Clostridium botulinum has got to be there in the first place. And there are some foods that are well associated with Clostridium botulinum, and there are some foods that are never associated with Clostridium botulinum. So in other words, you can do a risk assessment on this. The second thing is, if you've got Clostridium botulinum in your food, then you need a good process to kill it off. You do need to heat your food to sort of 90 degrees centigrade for 2 minutes or equivalent. So you'll need a very high temperature to kill off the Clostridium botulinum. You also need a food that's going to support the growth of Clostridium botulinum. Remember, it's not the bacteria that causes the problem, it's the neurotoxin. So if you've got a food that's too salty or too dry for the bacteria to grow, then it won't grow. If you keep your chilled food at 3 degrees centigrade or less, not as an aspiration, but actually keep it there always, Clostridium botulinum will not grow. Also, at the end of all that, you've got to have the person to become ill. They've got to ingest the toxin. So there's lots of steps there, if you like, as part of a risk assessment. And one of them, I'm using a table here from the Food Standards Agency guidance on chilled foods. Just to make the point, if you've got hot smoked mackerel, trout, or shellfish, there is a very high association with Clostridium botulinum with those foods. So therefore, you really need to make sure that in your system-based HACCP principles, you have an adequate process to control Clostridium botulinum. But if you're looking at something like cheddar cheese, it's a very low association because it's just not a food that Clostridium botulinum is very comfortable growing in. So there is a range of foods, and some are very high risk and some are low risk. So food safety controls, what do you need to do? Well, the first thing, there's several elements. Vacuum packing. You need to control the outgrowth of Clostridium botulinum and toxin formation. The two main ways of doing that in a chilled food: reduce shelf life. Remember, I said with sous vide, go back and find out how long your food is under vacuum. If it's less than 10 days in total, no matter how many times you've opened it and closed it, whatever, 10 days or less, then you're restricting the chance for Clostridium botulinum to grow and produce neurotoxin. If you're keeping it at 3 degrees centigrade below, and that's guaranteed, it's not just occasionally, but absolutely guaranteed, Clostridium botulinum will not grow. So these are the sort of things that are really helpful. The thermal process, well, you need a thermal process that's going to be equivalent to the 75 degrees centigrade catering temperature, or 70 degrees 2 minutes. You want something equivalent to that to kill your Salmonella, E. coli, and Campylobacter and all that sort of stuff. Cooling. You've got to be careful with that. Remember, if you've watched a video on Clostridium perfringens or cooling of food, you'll know that it's possible for Clostridium perfringens to survive cooking and then by forming spores. And then if you don't control cooling, it can grow out. And then you've got to prevent cross-contamination. Of course you have. So your systems based on HACCP principles needs to be properly thought through and validated. Now, the Food Standards Agency have issued guidance on this. There's lots of guidance out there. I said there's lots of stuff on our website in terms of the training website. But the things you need to think about, first of all, is if you're going to be sous videing, if that's such a verb, a food, is Clostridium botulinum associated with this food? If it isn't, well, then, there's no point. You're not controlling. It's not going to be there, is it? But if there's a high association, and things like fish particularly, it will be. You need to think about the control of the outgrowth of Clostridium botulinum in the backpack. Remember, it's temperature and shelf life. If you keep it below 3 degrees, it won't grow. If you keep it less than 10 days, then really you're in pretty safe temperature. As long as, when I'm talking about the 10-day shelf life, I am talking at chilled temperature, so below 8 degrees or 8 degrees and below. But you've also got the intrinsic factors. That means the factors within the food, the pH, the water activity, the salt content. These might form individual barriers to Clostridium botulinum or a combined effect. So there might be a need to conduct what is called studies on your foods. You might need to get a food technologist to have a look at this and conduct proper studies to see whether Clostridium botulinum will grow in it. The cooking temperature, which is the core temperature, the middle bit of the food. If you've decided that Clostridium botulinum could be present, so we're talking about fish, and if you're thinking, well, actually it could grow because we're not keeping it below 3, and actually we are keeping it quite, it's been in backpack quite a long time, then you need to make sure that the thermal process is equivalent to 90 degrees centigrade for 10 minutes. Because if you're going to do a cook for less than that, then there's going to be a problem. Now, your sous vide isn't going to be 90 for 10 minutes. There is an equivalence chart, and you can look at the Food Standards Agency website or on our training website, and you'll see that. But you're talking about, if you're looking down a cooler temperature, probably cooking for hours and hours and hours and hours to get to that point. If Clostridium botulinum is not an issue, then the cooking temperature you need to achieve is going to be 70 for 2 minutes or equivalent. So again, the cooking temperature might be lower and the period might be lower, but you need to just adjust your cooking temperature according to the risk that you've identified. Once you've cooked it, once you sous vided it, well then you need to make sure if you're going to be storing it, then it's stored at an appropriate temperature. Typically, in catering environments, it's served up and you might be doing other things. For example, you might be cooking it afterwards, which in some ways makes some of the concerns with sous vide not as important. Okay, well, thank you for listening to this. This is just one of 99 videos on food law topics. I hope you can join me on the next one. Thank you for listening.